Welcome back. In this video, we will do a couple of more questions using trigonometric identities. First one is a proof. We are asked to prove 4 sin square theta minus 3 cos theta plus 1 equivalent to 5 minus 3 cos theta minus 4 cos square theta. Similar to previous video, we will use this as a left hand side and this is right hand side. We will start from left hand side and we will get the right hand side. Left hand side is 4 sin square theta minus 3 cos theta plus 1. If you look at the right hand side, we have only cos, so we need to get rid of the sine. So we have sin square theta, and we can use the first identity, which is sin square theta plus cos square theta equal to 1. Therefore, sin square theta equal 1 minus cos square theta. So instead of sin square theta, I'm going to replace with 1 minus cos square theta minus 3 cos theta plus 1. If you expand the bracket, it would be 4 minus 4 cos square theta minus 3 cos theta plus 1. So 4 plus 1 equal to 5 minus 3 cos theta minus 4 cos square theta. This is equal to right hand side. So this concludes the proof. Let's move on to next question. This question is asking find the exact value sin theta if cos theta equal to 2 over 3. All right. So let me draw a triangle, right angle triangle, and let me say this is theta, and you know cos theta is adjacent over hypotenuse. In this example, cos theta is 2 over 3, so I can say 2 is adjacent and 3 is hypotenuse. Right, so let me put adjacent is 2 and hypotenuse is 3. This is a right angle triangle, so we can use the Pythagoras theorem. This is the opposite, and Pythagoras theorem says opposite square plus adjacent square must be equal to hypotenuse square. So opposite square plus 4 equal 9. Opposite square is 5, so opposite is square root of 5. Now we have a right angle triangle with all the sides unknown. So sin theta is opposite over hypotenuse. Let's say they have opposite is root 5, hypotenuse is 3. That is the answer for the question.